right, this is a practice page, so hopefully you'll hit pause, you'll work through things, you'll come back and check your answers. But just for fun, we'll go ahead and do the first one together, and then I'll have you come back and hit pause and try the rest of them. So 150 senators to 50 states. Well, whatever comes first, remember, goes in the numerator of the fraction. So 100 over 50, which does reduce to be 2 over 1. So as a decimal, that would just be 2. Your interpretation, well, whatever comes first is on top. So there are 2 senators for every 1 state. Nothing new, we all know that. Now make sure you check it out in the next 2, so you can do some conversions to make those in the same units. So 2 years is 24 months. So this one is really 18 over 24, which reduces to 3/4. 3/4 is 0.75, and therefore we would have 3 to 4 months is the ratio interpretation. Okay, hit pause, try the rest, and then come back and check your work. All right, so we reduced our fractions each time, changed them to a decimal by dividing. So in this case, we would take 17 divided by 12 to get our 1.42. And then our interpretations are 1.42 to 1 minute. They both have the same units. In the red, we have 150 bees per hive. That's per 1 hive. And then lastly, we have 0.067 faculty per 1 student. Remember, whatever comes first is in the numerator of your fraction. There are approximately 1,518,550 inmates in federal and state facilities in the 50 U.S. states. Part A, find the ratio of inmates to states and interpret your answer using a meaningful sentence. Okay, so we want inmates on top, states on the bottom. Well, there are 1,508, that's a comma, 550 over 50 U.S. states. So when I divide to reduce that, I get 30,371 inmates per state, because this would be like putting that fraction over 1. And remember, inmates are on top, states are on the bottom. So for every 1 state, we have 30,371 inmates. Now part B, if $8.35 billion are spent in healthcare for the inmates in the federal and state facilities in the U.S. each year, write the ratio of healthcare costs to inmates in a meaningful sentence. Okay, so billion. We haven't really gotten to this yet, but billion means 9. So I'm going to have 9 decimal places. So there's 3 and 5 represent the first 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. That right there is 8.35 billion, and we have 1,518,550 inmates. So if I go ahead and divide that in order to reduce, we're talking about money, so I'm going to round to the nearest penny. That means we spend roughly $5,498.67 per inmate on health care. That's what this is telling us. Healthcare costs to inmates. So healthcare costs on the top, inmates are on the bottom. Liquid weed killer is available in 2 sizes, 32 ounces for $32.79 or 16 ounces for $20.38. Cost per ounce. That means cost is on top, ounces are on the bottom. So we're looking at $32.79 over 32. And we're looking at $20.38 over 16. So we want to calculate this to determine the better price. Well, if you divide $32.79 divided by 32, you get $1.02 per ounce. You divide this one, and you get $1.27 per ounce. So if you can afford the $32.79, it's a better deal than the other one, because you're paying 25 cents less per ounce. Which you can kind of see that it's a better deal. Because 16 times 2 is 32, so that's double. But if you double $20, that's 40. and 32 is not 40. So you can tell kind of by looking that this one is the better deal. And last problem here, we're talking about age dependency ratios. So the table to the right has the number of people for each age bracket for a county in Indiana. Child dependency ratio. So remember, for children, we're taking children divided by the workers. So 6,734 divided by 21,241. That gives us roughly 317. Now, that's over 1. Remember how we talked in a previous video that if I multiply by 10, that would give me like 3.17 over 10. So I could say roughly 3 children are dependent on 10 workers. It's just manipulating the fraction by multiplying top and bottom both by 10. You can do that mathematically, not a problem. Now let's go to old age dependency. So now we're taking the oldies divided by the workers. So I've got old people, 5,528, divided by the workers, 21,241. When I divide those, I get approximately 0.26. Again, remember, that's like putting this over 1. So I'm going to go ahead and move this one 2 places. That gives me 26 over 100. So 26 old people are dependent on 100 workers. Just showing you different ways of interpreting. And then if we go to age dependency, so now we take our children plus our old people, and that gives us our total dependence of 12,262, and we divide that by our workers, 21,241, because that's everybody, right? We want the 0 to 14s plus the 65 and above, and divide that by our working class. We should have been 4s. Gives us a decimal of approximately 0.577. So over 1, let's go ahead and move that. So 5.77 over 10. So 5.77 dependents on every 10 workers. And there's your practice page on ratios.